Running. Yeah, very good afternoon to everyone out there from the Hibiscus Coast Astronomical Society. Thank you for joining us for our live stream that we've been doing over the lockdown and carrying on afterwards. Today we have got a really special treat. We've got Fraser Cain, and I know that many of you know who that is. So he does the Universe Today, the most brilliant news site. He's got his YouTube channel with all those Q&As and information up there. It's just really amazing. And of course, he's the co-host of Astronomy Cast. I'll get it right. And one of the best astronomy podcasts out there. And so it's a real treat. Thank you so much, Fraser, for doing this.
Problem. Happy to be here.
And let me just make sure everything's all going well there. Okay. So you're the guy who knows all the news out there. What's going on with Planet 9?
Well, how far back do you want to go? I mean, in 1929, they found Pluto. So you could go, Clyde Tombaugh found Pluto. You can go back that far. But after Pluto's deplaneting, there has been increasing evidence that there is some kind of massive object out there in the outer solar system. And a lot of the hard work has been done by a couple of people, a guy named Chad Trujillo and Mike Brown, also known as the Planet Killer. And most recently, Mike Brown and his collaborator, Konstantin Batygin, had done really extensive observations on a lot of the objects in the Kuiper Belt and found that there's some kind of influence or some large gravitational object that's out there in the outer solar system that is affecting the orbits of all of these objects. And so the sort of in the same way that Neptune was discovered by its gravitational perturbations on Uranus, astronomers think that there is some kind of massive object like another ice giant, but much farther out in the solar system. But fairly detailed observations have been made of the whole plane of the ecliptic, the region where all the planets go, and so far nothing has turned up. But the problem is that you need to do a survey. You need something that will show you a big chunk of the sky and then check night after night after night to see if you can catch anything moving through that region of space. And the best telescopes that do that right now, the best sky surveys, just aren't sensitive enough to be able to do that. There are telescopes which are probably capable of finding it, but imagine you're holding a hair at arm's length. Like, you can only examine this teeny tiny little spot at the sky, and think about how big the sky is. So we're really waiting on the Vera Rubin telescope, which is going to be probably coming online in 2021. And it's going to be doing an all-sky survey. It's going to be capturing an image of the entire night sky every 3 nights. It's going to take a picture to a very deep, very faint magnitude. And then it's 3 days later, it's just going to do it again. And then 3 days later, it's going to do it again.
Wow.
And by doing that level of constant observation, it's going to turn up these faint objects, asteroids, comets, supernovae going off, stars being variable, all kinds of really interesting things. I always like to say the stuff the universe does when we're not looking. So we are probably a year away, 2 years away from the instrument that will find Planet 9 and a lot of other amazing stuff coming online. Like, single-handedly, the Vera Rubin Observatory will find all of the dangerous asteroids to Earth. It's gonna revolutionize astronomy. So that's where we're at in Planet 9. Stay tuned.
So just recently they were talking about it could be a primordial black hole. What are your thoughts on that one?
Well, that's that's a really out there idea. And so the idea of a primordial black hole is that like right now, there are only two kinds of black holes. There are the stellar mass black holes, the ones that are formed when a big star dies and implodes and creates this black hole. And then you have the supermassive black holes, the ones that formed early on in the universe, either directly through huge clouds of gas coming together or through mergers of black holes and then gobbling up other material. And they've grown to millions of times the mass of the sun. But there is a minimum mass that you can get of a black hole from this supernova explosion. But one of the theories is that if you go back to the beginning of the universe, there could be these overdensities, like ripples in space-time, where the universe was so dense that black holes could kind of form in the folds of space-time, and they could be all different masses because the early universe was this extreme time. You could have black holes with the mass of a house, and black holes with the mass of a star, black holes with the mass of a planet, and they could be out there drifting around. And so the theory is that one way to have a gravitational influence of an object that you can't see would be a primordial black hole. But nobody's ever observed any of these primordial black holes. They've essentially constrained how much of them out there could be by very massive surveys of stars and galaxies, but they haven't disproven them yet. But for it to be a black hole, you need to have a black hole with the mass of an ice giant that somehow ended up in orbit, in a nice orbit around the solar system, and that we haven't been able to detect. But so it hasn't been ruled out, but there's no good reason to believe that's what it is.
So are you leaning towards an actual planet?
Yeah, I think the expectations are, number one, it's an ice giant, some massive world, a much bigger Kuiper Belt object, so something Pluto on steroids. And then the other possibility is that, as the Vera Rubin, the other possibility is that it's not really there, that it is a statistical anomaly, that the amount of data that's been seen so far, it indicates that there might be an object out there, but if you gain a ton more observations, you might get to a point where you say, oh, actually, there's clearly nothing out there. And so again, this is what the Vera Rubin Observatory will do. It will either find Planet 9, or it will find hundreds of other Kuiper Belt objects that then astronomers can do a much better survey on to try and figure out if it's out there. So again, stay tuned. I wouldn't put your hopes on it being a primordial black hole, but if it is, yeah, there's some interesting ideas on how you might detect it. Like, you might be able to detect comets, because when things do smash into a black hole, you get this burst of gamma radiation right from the event horizon. It's a very high energy kind of radiation, and so in theory you could detect it as it's moving through the outer solar system. But again, don't hold your breath.
So one of the things that I was reading on your Universe Today sometime, probably I think about a week or two ago, was what would happen if a supernova went off next to a black hole. Now, all our guys here, we've just been going through a series on sort of supernovas and black holes. So that was a perfect article. So
yeah.
Well,
that was my question show. I think that was the last question show that I did.
Yeah.
And so that's on the YouTube channel. And so I just get people want to know the astronomical equivalent of, like, who would win in a fight, the Superman or the Hulk, right? Spider-Man or Batman. They were wondering, like, people have just been trying to figure out ways to destroy black holes, and the answer, of course, is that you can't. That no matter what you do to a black hole, you're just going to make it stronger. Back to the Hulk analogy. If you shoot it with a bullet, it'll eat your bullet and become stronger. If you shoot it with a laser, it will eat that laser and become stronger. If you try to throw an antimatter amount of black hole at it, it will just eat that too and just get stronger. So there's really nothing that you can do actively. But people say, well, what if you exploded a supernova right beside a black hole? And if directly, nothing would happen. Black hole would enjoy all of the material, all of the energy, everything that you could throw at the black hole, gobble it all up and ask for seconds, no problem. But if you did have sort of the star and the black hole going around, you know, before you get a supernova, you had a star. And so that star would need to explode. And so you're going to have the star and the black hole. They're going to be orbiting a common center of gravity. They're going to be like a binary system that's going around itself, right? And depending on how massive the star is, that will define what's going to happen to the black hole. Now, if the star is in the, say, 15 or 8, I think, you know, in the teens to about 50 times the mass of the sun, then when it explodes, you're going to be left with either a neutron star or a black hole. And so now, before you had the star, now you have a neutron star, a black hole. It's going to change the way the orbital interactions work, but they're still going to be orbiting around each other. And then all of that material that was exploded out of the supernova is, you know, it's going to get gobbled up by the black holes as it hits it. But no great change. But if the star was a lot more massive, once you get into the hundreds of times the mass of the sun, the theory goes is that these stars will actually blow themselves up completely. They'll just disappear. That they will throw all of themselves, they'll essentially hurl themselves entirely out into space, and with an enormous amount of energy. And so you would have this black hole and the star that are going around each other. The star explodes and literally just is no longer there. And now the black hole no longer has this anchor that's holding it. And so it's just free to just spin out and head off into space in whatever direction, kind of like a slingshot. So, and then of course you wouldn't want to be on the receiving end of that black hole hurtling through.
I was going to say, hopefully not this direction.
Yeah, but I mean, we don't see any evidence that a black hole has come through our corner of the solar system in the last 4.5 billion years. So there's no reason to believe it's going to happen anytime soon.
So one of the interesting things recently has been Betelgeuse. Now, we pretty much know that that's not going to supernova anytime soon, but so projecting a bit into the future, what can we expect from Betelgeuse?
Well, we don't know yet, really. Now you say we won't expect it to go blow up anytime soon. Well, we don't know. Like it, from what astronomers know, Betelgeuse is in this end stage as a red supergiant star. It's in the very end, you know, and it is a very massive star with dozens of times the mass of the sun, and they're very short-lived. They only live a few million years. They burn hot and then they expand out as this red giant, and then they go through these various end phases, and then they explode as a supernova. And it's very hard to find a lot of these stars and really track down exactly where they are along this timeline. But at some point within probably the next million years or so, maybe even 100,000 years or so, it's going to explode as a supernova. It could happen tomorrow, or it could happen 100,000 years from now or a million years from now. We don't know exactly when this is going to happen, and we don't know any way to get any warning that it's about to happen. Maybe I'll talk about this in a second. And so, but what is kind of interesting is that, like, as these giant stars are dying, right? Like what's happening inside the core of stars like Betelgeuse is you've got fusion, like our sun. You've got hydrogen being turned into helium, and then the helium is getting turned into heavier elements. And as the star runs out of basic hydrogen in its core, it switches to helium, it switches to these other heavier elements, and it moves all the way up the periodic table of elements until it reaches iron. So it's turning carbon and it's making neon and all the stuff, and then it reaches iron. And so the thing is that with creating hydrogen or turning hydrogen to helium, it is a exothermic reaction. So this process releases gamma radiation in the core of the star, and that radiation is this outward light pressure that is keeping the star inflated against the gravity that's attempting to push it inward. And so when you get this iron at the core of the star, it no longer is producing energy. And so literally that outward pressure that's going on in the star just shuts off, and then the star implodes, and that's how you get the supernova. But what's interesting, this really neat idea, is that as it's in the final stages of dying, and even as it's dying, it releases a tremendous amount of neutrinos, which are, of course, these particles are streaming from the sun all the time. We detected them from the supernova 1987A, the one that was in the Large Magellanic Cloud.
Yeah.
And so we know that when a star goes supernova, it releases this burst of neutrinos. And the thing that's really interesting is that neutrinos are not affected by anything. They're not affected by matter. You could have a neutrino on average go through a light year of lead and not be stopped. And
Wow.
it'll go it goes just a fraction shy of the speed of light. And so the idea is that as the star is going through this process and as it's mid supernova, it's going to be releasing these neutrinos. And the neutrinos aren't blocked by the star at all. They just come out. They just make their way directly out in a straight line right through all of the stellar material. They don't care. But the light, as we saw before, the light is bouncing around and causing this outward pressure. And so the light is blocked. The radiation is blocked by the stellar material that needs to get out of the way in this supernova explosion. And so we may get several hours of notice, 4 hours, 6 hours of notice as the neutrinos arrive at Earth, because they were able to just get out of the star. They're not going faster than the speed of light, but they get a head start on the light itself. And then the star explodes and the light gets out, and then we see the supernova explosion. And so the thinking right now, and there's actually this network of detectors that are scanning the sky looking for a burst of neutrinos, and when they detect it, they will let astronomers know that this burst has gone off and start watching the sky and wait for a supernova. And it's going to be a close one. And then as these neutrino detectors get better and better and better, we should be able to scan farther and farther out into space so that we will have this advanced warning system for when these stars are going to go supernova. And so we may get a couple of hours notice for when Betelgeuse is actually going to explode.
So which star do you think is going to be the most likely candidate in our neighborhood?
Yeah, the most likely one is one that you can see in the southern hemisphere. It's a star called Eta Carinae.
Yeah.
And we can't see it in the north, but you can see it in the south. And it is a star that is about 50 times the mass of the sun, and it is super close to exploding again. But again, could be tomorrow, could be in 100,000 years. We don't know. But it is the star. It had an outburst. It's had several outbursts that have made it brighten up significantly, and then it's faded off. And people have built animations. You can see this material as it's sloughing off its outer material and sort of compacting down, and then it expands out again and throws out sheds another layer of material, and it's going to go any day now. So that's the one that's probably going to be the one that we all see first. But it could also just be one that we're not expecting. I mean, it's a big galaxy, and on average, we get one supernova every 100 years or so. And it could happen anywhere in the galaxy.
Well, let's hope it's while I'm still alive, because I'm really looking forward to seeing that.
We're due. I think the last one that's in recorded history was about 400 years ago, which was, I think, Tycho's supernova. Right. Anyway, so we are due for a supernova.
So just jumping around now a little bit further into the galaxy, fast radio bursts. What are they?
Nobody knows. Yeah. I mean, it's a true mystery right now. These idea of fast radio bursts, these are these flashes of what's happening was astronomers were doing various work in the radio spectrum. And every now and then they would see this really bright flash in the radio spectrum, but then they turned the telescopes back and it never returned. And so they're really tricky to find. And then in the last couple of, for a while there, astronomers were just trying to theorize what these actually are. Are they a bounce of radio waves off of a satellite that's going around the Earth? Are they something farther out in the galaxy? Are they something that's outside of the galaxy, out in the distant universe? And only in the last couple of years, astronomers have gotten a much better sense. There was actually an instrument out of Australia that is farsighted. So it's unable to detect objects which are within the solar system, but it is able to detect stuff that's out in the galaxy and beyond. And so for astronomers, like, we're pretty sure now fast radio bursts aren't bouncing off of satellites. But then there's this great telescope out of Canada called the Chyme Telescope, and it looks like a bunch of like half pipes, like skateboard half pipes, and it is a really fantastic radio instrument. Its job is to search for some of these radio emissions from as signals shortly after the Big Bang, but it also happens to be the perfect instrument to scan for fast radio bursts. And so with this telescope, with Chyme, astronomers have been able to find hundreds of these objects. And most of the time, it's the same problem. You see this burst, and then it's gone, and you scan the area again, and nothing ever happens again. So what is it? Right now, people are still trying to put together theories, and they're all over the map. The most conventional ones, I mean, obviously, whenever something really interesting happens that's really far away, and now they're fairly certain that they're happening outside of the galaxy itself. They have something to do with black holes, something to do with neutron stars, something to do with the rotations of neutron stars in very intense magnetic fields. They've thought about things like neutron stars, although they're under incredible, these are dead stars, or have incredible gravity. They actually do have almost like plate tectonics in them, and so their crust can, as they cool down, their crust can crunch in, and in theory maybe you get some kind of burst of radio waves as the neutron star is crunching down a little bit. And of course, some of the more exotic ideas are maybe it's aliens trying to communicate with us. But to go back to the conversation we had about primordial black holes, but even less likely that it is aliens.
Now, talking about aliens and communication, you had another interesting article about how language will change on interstellar sort of flights. Can you go into that a bit more?
Yeah, well, I mean, it's a fairly it's an interesting idea. But I mean, this idea that for example, we are both come from England originally, our countries. And the language that I speak, the English that I speak, and the English that you speak are different slightly. We can understand each other, but we are our languages in Canada and yours in New Zealand have changed from the Queen's English, and so that continues over time, and over time it gets to a point where they actually diverge and they become completely different languages, and we're no longer able to understand each other. And so this idea of sending people to another star system, there are all these interesting issues that will be involved with it. How will they have enough supplies? How will you keep people alive through potentially multiple generations? How much genetic diversity will you require to be able to, for people to actually be healthy multiple generations down the road? And then a couple of linguistic researchers asked this question: how will language change? Will we be able to understand them when they arrive at their destination? And it's sort of taking a small group of people, potentially a few hundred people, keeping them in a situation, in a social environment that is dramatically different from what they would be experiencing back on Earth. They're having different issues, problems. They're going to have 100 words for radiation, and how would that language change over time? And so Matt Williams, one of our writers on Universe Today, wrote a great article just about looking into their research and then using some simulators to try and show how over just a few dozen generations, our language would change quite significantly to the point that we wouldn't be able to understand them.
So looking at sort of colonizing out there, I think Mars is looking as the most likely candidates in the near term. How near term do you think that would be?
Well, I have a pretty controversial opinion about this as a person who has dedicated his life to space enthusiasm. I don't think that we're going to be settling Mars really until it becomes effortless. So right now, it is the hardest engineering challenge we can possibly conceive. You take attempting to live on Antarctica and you multiply it by 100. And nobody wants to go live on Antarctica. Like, I mean, there's some research stations, but generally, if you want to try to live in Antarctica, then death is what awaits you because it's brutally cold. There's nothing to eat. There's not enough sunlight for growing anything. It's terrible. It's really hard. And Mars is like that, but also you can't breathe. Also like that, but there's deadly radiation that's streaming down. Also like that, but you are a year away from any kind of help. Run out of toilet paper, you're gonna have to wait a year for it to show up. You are an hour away from being able to have any kind of communications with Earth. So it is a technical challenge, the likes of which humanity has never seen before. And there's no real benefit. There's no reason. Like, you can understand if you go down to Antarctica, there is a population in Antarctica. I don't know what it is. It's in the hundreds, right?
Yeah, yeah.
You know, where people are doing research. They're trying to figure. They're doing climate science. They're doing astronomy. They're doing research in the area. And then the support to keep these people alive. And over the wintertime, the group shrinks down to the bare minimum, and that's what you're facing, because there's no real practical reason to go live in Antarctica. Anything you want to do, you can do easier anywhere else on Earth. You go to Antarctica because there's a few things you can only get from Antarctica, and you can't do unless you're there. And so the same thing goes for Mars, that there is a tremendous amount of science that needs to get done on Mars. We need to understand the geology of the planet, the climate. We need to search for life in a place that's completely different from Earth. And then we also need to test out the kinds of technologies that will allow humans to live longer and farther away. So there's real value for us sending humans to Mars in a research capacity, in the same way that there's value to sending humans to Antarctica in a research capacity. But this larger idea of colonizing Mars as a place to live that's not Earth, I think that people will get less enthusiastic about that idea as the reality of the difficulty, just in the same way that people have tried to settle Antarctica. There's been many attempts for people to go and set up a home on one of the coasts of Antarctica, and they give up because it sucks.
Yeah.
Right? It's just hard. It's just hard living. You want to go somewhere else? Like, New Zealand is nice, right? Why live in Antarctica when you can live in New Zealand?
Exactly.
You want to have a hard struggle? Go somewhere that's less inhabited but still has really nice trees and a
Like
beach.
Canada.
Yeah, same thing in Canada. You want to live a difficult life? Come to Canada. We got plenty of room in the middle of the country all the way north. You can survive your little heart out, and so and you get to breathe, and there's food to eat, and the sun is up, and you get to enjoy liquid water that flows around, and all of these other good things that the environment is giving you. So I think that in the short term, I think we're going to see some people definitely go to Mars, go to the moon and Mars for science purposes, some kind of research station. People are going to discover and explore, and we will probably have humans on Mars permanently from within a decade from now, forever. But I don't think that in the short term, we're really going to have a large number of people until our technology gets so good that it is effortless.
Now, that was my thoughts as well. If you want to have a go out there, it's all very well, but we've got a body just up here which is just as good, and it's closer, being the
Well, I
moon.
mean, the moon is as bad as Mars.
Yeah,
So, I mean, both, I mean, again, any place that you're going to try to go that is not Earth is going to be a desperate struggle for survival, the likes of which humanity has never known forever. Well, not forever, for a few hundred
it
years.
is. Yeah.
But then we will get to a point where our technology has matured, that we have regular rockets, that we have the ability to, we deeply understand how to supply all of the requirements that humanity needs to survive in space. We will have abundant energy. We will have manufacturing processes. We'll have safety processes. We will understand how to make food at a vast scale. Then suddenly all of that makes sense again, and you have these gigantic rotating O'Neill colonies. You'll have so I think that in the short term, settlement of Mars isn't going to happen as quickly as everybody is hoping, but in the long term, there could easily be 1 trillion people living across the solar system, because we will have mastered the technology of space exploration. So, but it'll be beyond our lifetime. It's going to be in the hundreds of years, not in the decades.
So you mentioned discovering some forms of life on Mars. We've sort of seen that there's liquid water now, like pretty much all over the show. I mean, just recently they were saying Pluto has a liquid
Yeah,
water center,
yeah,
which just blows my mind.
yeah.
So, which of all these watery planets, or moons, I should say, do you think is most likely for us to find some form of life?
Yeah, I mean, there's kind of 2 classifications. There's Mars is the one classification, and then there's all of the ice worlds, the water worlds, Europa, Enceladus, Pluto. I mean, could be all of them. Triton, Haumea, like every one of the Kuiper Belt objects could have some kind of liquid ocean. There could be hundreds of these liquid worlds around, all covered in this ice shell with some thickness of ice shell and some amount of water underneath. So, for the water worlds, we'll take a place like Europa. It's a pretty exciting candidate, because we know that there is an ocean of probably some kind of salty water that is underneath this thick ice layer that will protect the life from radiation. But there's some kind of volcanic process at the bottom of this ocean that is putting some of the raw chemicals for life into the water, that is then floating up through and bubbling up to the surface. So at this point, planetary scientists are very certain that there's liquid water, that it has the kind of food that bacteria likes. There's energy for bacteria to subsist on. Really, the conditions that we have down at the bottom of the oceans here, where we've got these black smoker volcanic vents that are connecting from the mantle of up to the bottom of the ocean. Those same conditions could be on Europa and Enceladus and Pluto and all these places. And that's really exciting, because you've got everything that you need for life. The challenge, of course, is that they're covered by dozens of kilometers of solid ice that you're going to have to figure out a way to get through to make any kind of observation. So life seems more likely in a place like that, but harder to find out. Although we have this little thing that's quite lucky, that you've got these geysers that are blasting out of Europa and Enceladus and Triton, almost certainly. And so a future spacecraft could set down beside one of these geysers and maybe sample this material that's coming out of the world, and maybe find life that way. With Mars, you've got a much worse environment. Obviously, on the surface, the temperatures are very cold. It's constantly irradiated. The soil is filled with these perchlorates, which are a kind of poison. But at the same time, research has shown there's probably vast reserves of water under the surface of Mars. Probably some kind of salty solution that keeps it liquid even under a tremendous amount of cold. So it seems like there's good conditions for life under the surface. But it's funny. There was an experiment on board the International Space Station where they they took a bunch of life forms, the toughest Earth's toughest life forms, and they exposed them to the vacuum of space. They just opened up these. They had like cyanobacteria and lichens and things like that, and they just exposed them to space for years, for like 2 years, and then they closed up these capsules and they brought one and brought it back to Earth conditions, and most of the life forms were ready to go again and just started recolonizing. But they also kept some of these life forms and exposed them to conditions which were on Mars, and a couple of them were ready to go. So you take cyanobacteria, which is like Earth's toughest life form, and one of the most common. Cyanobacteria can go and spend, you take it from Earth, nice, happy home, you take it to space, you expose it to the vacuum, hard vacuum of space for years, you close it up, you take it to Mars, and you open it up on Mars, and it's like, let's go. We're ready to go. This is delightful. I can't wait to colonize this place. So, and that's of course why this idea of planetary protection is so important. We have some really hardy, really capable life forms here on Earth that would love a shot at living on Mars, and whoo boy, would they love to go and live in the nice warm oceans on Enceladus or Europa. So we have to be really careful that, you know, if we contaminate these places, we'll show up and you're like, wow, what do you know? We dig in the ground and there's cyanobacteria, and we dig in the oceans and there's cyan everywhere we go, and it's all related to us. Wow, that's weird.
Oh, that's the thing, because you can't ever get rid of it. Totally. You go to that planet, you're taking them with you.
Yeah, absolutely.
Some description. Okay, jumping around a little bit, James Webb Telescope. What are you hoping for? If it ever gets up there.
Oh yeah, it's gonna launch. It's gonna launch. The previously was expected to launch in March 2021, and this was after a very extensive review from NASA of its supplier. I think Northrop Grumman is building it, and so they'd identified a bunch of issues and they'd pushed the timeline. You know, obviously it was originally supposed to launch 10 years earlier, but here we are in 2021. And then about 2 months ago, we learned that, yeah, it's going to be delayed again, but now it's probably going to be delayed into late summer 2021. So the delays are getting smaller as the telescope is getting more and more completed. And at this point, it really is essentially complete. The telescope has been folded up. It's all of its shake tests have been done. All its heating, cooling, vacuum tests have been done. All the instruments are ready to go. And the next big step is for it to be put onto a cargo ship and taken down to South America, where it's going to be launched again sometime in August-ish, or late summer, early fall. I'm sure it'll be delayed, but it's it's a $10 billion telescope. Be careful. So yeah.
So what are you hoping for with James Webb? If you had your top two things.
Well, sure, yeah. So there's two big questions that James Webb is going to try to help answer. One is there's this age after the beginning of the universe. So we have the time when there was the Big Bang, and about 300,000 years after that, the universe had cooled down to the point that light could finally escape out into the universe. And we now see that as the cosmic microwave background radiation. But the universe, when the light got out, the universe was dark. And then the first stars formed from, as this hydrogen is out there in the universe, and then the stars formed, and then they started to blast out radiation, and they started to make the universe glow again. And that is the epoch of reionization, and this time in between is called the Dark Ages. And then after this epoch of reionization, then these stars started to form together into galaxies and form these first big structures. And that's what James Webb is going to be able to see. Right now, Hubble can just barely see some of the oldest galaxies in the universe. James Webb will directly be able to see right to the beginning of all of these galaxies forming, no matter where it looks. And that's really exciting because it's going to answer a ton of these questions about how did the pieces come together to form the big, beautiful spiral galaxies that we see today? Why do we have the variations that we do? Did they come together in one single thing, or did they come together as a bunch of little dwarf galaxies that just kept building and building up over time? Why did some end up as spirals? Why did some have bars in their spirals? A lot of that you have to go right back to the beginning. So that's the first big thing that James Webb is going to be able to do. But the second big thing is that it is going to be able to, closer to home, it's going to be able to observe exoplanets, planets orbiting other stars, and be able to directly observe the atmospheres of these planets.
Wow.
And that is, I mean, that's barely been done at this point, but James Webb will be able to take it to the next level and be able to observe potentially the atmospheres of Earth-sized worlds orbiting around sun-like stars. And so suddenly you've got this ability to sniff the atmosphere of a planet that's very much like Earth. And if you were to sniff the atmosphere of Earth, it would be fairly obvious that there's life here. There's vast amounts of oxygen in our atmosphere. There are trace amounts of other chemicals like methane and carbon dioxide. There are pollutants in our atmosphere from humanity. And in theory, these are the kinds of things that James Webb could be finding in the atmosphere of a whole other planet. And so it's probably premature, but James Webb could, if there was a really obvious signal of life in some other planet, James Webb could find it, which would be incredibly exciting because we would know for the first time that there's probably life on another star system that we can see. So that's incredible. But most likely, James Webb is going to be like the Hubble Space Telescope, that there are going to be these discoveries. There are going to be these amazing finds that we had no expectation that we were going to find. It's going to be the unknown surprises that I'm most excited about every time with these telescopes.
So, talking about excitement, what is exciting you the most at the moment?
Well, right now, the thing I'm most excited about is that there's a visible comet in the sky that we can actually see.
About time.
I know, it's about time. Well, you guys had McNaught, but we
Yeah.
didn't get it. So we never had a really good view to Comet McNaught.
Well, we're hoping just in a week or so that we might get a glimpse of NEOWISE before it disappears.
Yeah. And so I think for us in the northern hemisphere now, NEOWISE just pushed into being a evening object, which is very convenient because I much prefer early evening objects as opposed to early morning objects.
You and me both.
Yeah,
I'm
yeah,
not an
I
early
like
morning person.
Yeah, exactly. I like to go out with my scotch, and like look off to the west and go, oh, look, there's a comet. That's nice. It's very civilized as opposed to getting up, getting the family up, oh, okay, guys, let's go look at the comet. Dad, come on. You're never going to see this for 20 years.
Yes.
All right, fine. Yeah. So it's a much different experience when it's an evening object.
So,
But yeah,
so have you
really
actually
excited.
been out and seen NEOWISE?
No, it's been cloudy and rainy here for the entire time. I haven't had a single clear night, and it's weird because we're in the middle of July, so we should be having a nice, hot, dry summer. But it's been incredibly wet and miserable. I mean, I'm still wearing my coat in the middle of summer. It's not right.
It's down here as well. I mean, winter.
Yeah.
Unfortunately, we get a lot of winter rains, which kind of wash everything out. But on those clear days, clear nights, oh man, the views are unbelievable.
Yeah.
Of course, we're lucky down here. We've just got that Waiheke Dark Sky Park.
Yeah.
Just on our doorstep here, up in Auckland, we've got Waiheke Dark Sky, which is an island, and then we've got another one called Great Barrier Dark Sky.
And the island was just designated as an international dark sky site.
Yeah. So these are all pretty much on our doorstep, which is fantastic.
Yeah.
But
I mean, I remember Hyakutake and Hale Bopp 20 years ago, and they were incredible. Just such a wonderful sight to see in the sky. And we normally would have them more commonly, but it's been amazing how rare they've been. So
this last few years,
yeah. So I think this is and this one is not as good as they can be. I mean, a comet can be incredible, but we get what we can.
For me, it was Halley's Comet which got me really going into astronomy. I'd loved
Yeah,
astronomy before, but seeing Halley's Comet and realizing that I might not be around when this thing comes back again,
yeah,
that really blew my mind. And since then, I've really liked the old comets. But
yeah, yeah.
Southern Hemisphere, we tend not to get them as many as you guys get them up north. um,
Well, I don't think there's any rhyme or reason to it. I mean, it's just luck of
yeah,
the draw. Yeah.
but it's quite interesting for everyone out there that you do these virtual star parties as
Hmm.
well. I wonder if you could just let them know what you guys get up to and things like that, because it's quite interesting for a southern.
Sure. Yeah. Yeah. So every Sunday night, when we're in our active season, so right now we're on hiatus right now. So we take July and August off, but for the rest of the year, every Sunday night we hook up a bunch of telescopes onto the internet, and then we just see what we can see and see what's up. And we bring on experts to talk about some of the objects that we're looking at and answer questions about astronomy and observing and about telescopes and astrophotography and so on. It's a good time, a couple of hours, and we even have a couple of people from New Zealand from time to time who will show us their view during the day while it's nighttime for us.
Yeah, so if anyone's interested, I've been to a couple of them, and it's really fantastic. It's nice to see some of those sort of northern sky
Yeah, we've got
objects,
your
which,
galaxies.
yeah,
Yeah,
um, but maybe we can do the same one evening and let you guys see the southern skies.
yeah, that'd be. I would love it. I mean, that's the one thing that I still need to figure out as a way to bring in the southern skies, because there are all these objects that we just can never see, and and unfortunately, I need to find somebody in South America, because somebody in Chile or something, because your daytime and our nighttime are flipped around, and
I
so
know.
unfortunately I can't get night views from New Zealand at the same time they're getting night views from Canada or from North America. So I do, but I love getting the we've got an astronomer in Malaysia who joins us, and he's bringing us daytime views of Venus and
Wow.
Jupiter and the moon and stuff, because he's really good at what he does. So
Yeah.
it's kind of amazing what's still possible even in the daytime.
That amazed some of our members that you could actually see things like Venus and Jupiter during the day.
Yeah, yeah,
As long as you
exactly.
know where to point your telescope, and you've
That's
got a
right.
big
Yeah,
enough
you let a
telescope.
computer figure out where to point your telescope. Watch out for the sun.
Love the go-tos.
Yeah,
Yeah.
exactly.
Um, so I wonder if you could tell everyone else about all the other things you get up to, University,
Sure.
Astronomy Cast, all of those.
Yeah, well, I mean, so my day job is I'm the publisher of Universe Today, which is a space and astronomy news website that I've been doing for 20 plus years now. And as you mentioned, I'm the co-host of the Astronomy Cast podcast with Dr. Pamela Gay. She's a PhD astronomer, and every week I just get to ask her a bunch of questions about space and astronomy, which is great. We talked about the virtual star parties. I also do a weekly email newsletter, which I think a lot of people really enjoy. It's kind of like a magazine at this point. I'll cover about 15 to 20 stories about
Wow.
space and astronomy that I'm interested in. It's really like a full high level view of just everything that's going on in space that week. And that comes out every Friday, my time, whenever I get around to writing it. So you can get that from universetoday.com/newsletter. Totally free, no ads. It's and I think it'll take you a couple of hours to go through. Um, but yeah, and then apart from that, just continuing to do that and all the videos that we do on YouTube as well. So the question shows, this kind of like this, um, and then I do a bunch of live shows and shows with guests, and then we also do the weekly Space Hangout, which is a weekly news roundup where we talk about all of the interesting space news for the week. So we got you covered for space and astronomy.
So I've got a couple of questions here. Uh, Chris Benton has asked, has the 30-meter telescope been approved in Hawaii, Mauna Kea?
No, it hasn't. The There's quite a controversy about the 30-meter telescope in uh, for the last couple of years from the indigenous Hawaiians. And although they are having some conversations and working, the whole project is on hold at this point. There is some potential to move the project to the Canary Islands. Spain
Wow.
has said, anytime you want, we're ready to go. But and although Canary Islands are a fantastic place, Hawaii is still better. And so the first choice is to work through the issues, get some kind of resolution and continue building the 30-meter telescope in Hawaii. But if they do continue to reach an impasse, they'll shift the location to Canary Islands. But right now, we're still kind of in the middle of it.
So, what sort of telescopes have you got around Canada?
Not much in Canada. I mean, we've got the Dunlap Observatory. I mean, we've got some older research telescopes that are now more like open to the public. So we don't have any really good. I mean, as I said, we've got the Chyme Observatory. We have a space telescope, the MOST telescope, but we don't have like really big dark sky, high altitude telescopes the way they have in the Southwest. We just don't have the right conditions in Canada to have a really good observing spot.
Yeah, I must say I've been to Canada a few times, and sleet and overcast and rain is kind of the order of the day for most of the year.
It'd be pointless to set up a telescope in a lot of parts. I mean, it depends where you go, but
I imagine you have some really good dark skies once things clear.
Yeah, for sure. And if you want to see the auroras, we've got some great views to the auroras, but you just can't compete with a place like Hawaii or Chile, where you've got a desert, incredibly high altitude, so the skies are clear. There's no atmospheric turbulence, and it's perfect.
Let's see. There doesn't seem to be any more questions. So,
Okay.
thanks very much, Fraser. Like I say, I really, really appreciate this. It's been really fantastic. Hopefully, we can join you on the virtual star parties when they start up again. For everyone out there, I will be putting all of Fraser's links into the Facebook group. I'll also email them out to everyone. So everyone out there, thank you very much for joining us. And like I say, really appreciate it, Fraser. Thanks so much. So I'm going to just